The question here is to find current through each branch. This diagram looks like a Wheatstone's bridge, but the ratio of resistors are not equal. 10 upon 5 is 2, 5 upon 10. The resistor here is 5 ohms, 5 upon 10 is 1 by 2. So normally by feeling like Wheatstone's, all will go for the current through BT0, but here the resistors are not proportional between AB and BC. AB to BC is 10 by 5, AD to DC is 5 by 10. It's left 5 here, it's 5 ohms. So we cannot apply the balanced Wheatstone's condition. So we need to go for Kirchhoffs laws. So take one loop ABDA. Before that, the current coming from the cell splits at A into 2. Current through AB is I1, current through AD is I2. To avoid number of unknowns, the current entering A is taken as I1 plus I2. So I1 plus I2 is splitting as I2 and I1 here. If we take I here, there will be another unknown. It reduces the number of unknowns. If you are taking AB as I1, AD as I2, you can take the current entering as I1 plus I2. Now at B, or at B, current can split, but we are imagining current at B is splitting. So one current will go towards B as I3. The remaining from I1 minus I3 will go to BC. The current entering B to D and A to D will add up. I2 plus I3 will go through B to C. The current entering from B to C and D to C will add up. I1 minus I3 plus I2 plus I3. So minus I3 plus I3 get cancelled. We get I1 plus I3. The current starting from the cell is coming back to the cell. So we are applying the voltage rule, the loop rule, to first loop ABDA. So minus 10 I1 minus 5 I3 plus 5 I2 equal to 0. Current is moving from positive to negative. When you take the voltage as per one convention, you take the final terminal of the resistor from where you leave. So plus to minus is minus. Current go from plus to minus, so this also minus. Current is going from plus to minus, we are going from D to A, so it's plus 5I2. Minus 10I1 minus 5I3 plus 5I2 equal to 0. One can reduce dividing by 5. So minus 2I1 minus I3 plus I2 equal to 0. If you just multiply with common negative, so this will be plus 2I1. Or if you write I2 next, it will be minus I2, then plus I3. Just to keep the order and keeping the first term as negative, not compulsory. Divided by 2 multiplied by a negative sign, then we just arrange I1, I2, I3 in the order. Now second loop we are applying for starting from B, B, C, D, B. Here the current is going from B to C, so minus 5 into I1 minus I3. But these currents are opposite, so 10 into I2 plus I3 plus this also 5 into I3 plus, totally equal to 0. Now you open the bracket here minus 5I1, that is minus 5I1, plus 5I3, 10I3, 5I3, so total 20I3. So I2 is just 10. So we can rearrange it as before again I1, I2, I3 order and multiply with negative sign just to keep the first term positive, which is not compulsory. So 5I1 plus minus 10I2, it was plus 20I3 minus 20I3. Again divide by 5, so I1 minus 2I2 minus 4I3 equals equation number 2 is equation number 1. There are 3 unknowns. For solving 3 unknown, we need 3 equations. So already we took a loop ABDA or BCDB. Now don't go for ABCDA. You get the same equation only by solving it. Take a different loop. Either ABCEA or ADCEA. So ABCEA if you are going, A to B again minus 10I1 minus 5 into I1 minus I3. Nothing here. There's a voltage here, that's plus 10. You're leaving from the positive terminal plus 10. Here again you're going from right to left. So this will be negative sign here. So minus 10 into I1 plus I2. Minus 10 I1 minus 5 into I1 minus I3 plus 10 minus 10 into I1 plus I2 equal to 0. Here minus 10 I1 minus 5 I1. Again minus 10 I1. So 10, 5, 15 plus 10, 25 I1. Then I3 will be just plus 5 I3. So I2 is minus 10 I2. Then there's a 10 here. So rearranging this, I1 is 25 minus 25 I1. I2 is minus 10 I2. So I3 is minus 5 I3. That's equal to minus 10. It's minus 5 I3. So when you divide by 5 and multiply with negative sign, it will be 5 upon 5, 25 upon 5 is 5, 10 upon 5 is 2, 5, it was 5 here, 5 upon 5 is 1. So multiplying with the negative sign, minus become plus, minus become plus, plus become minus, it's equal to, divide by 5 is 2, minus will be 3. Now 3 equations we have, all the 3 we have I1, I2, I3. We are trying to eliminate one of them. So we take first equation. The equation is 2I1 minus I2 plus I3 equal to 0. We just mark it as true. Then this equation is I1 minus 2I2 minus 4I3 equal to 0. So I am multiplying with 2 so that I am getting 2I1 common. I can subtract later to eliminate I1. So multiplying with 2, so 2I1 minus 4I2 minus 8I3 equal to 0. Now you can subtract a minus b. So 2I1 will go, minus I2 minus 4I2. So plus 4I2 will be 3I2. I3 minus I3 will be 9I3 equal to 0. So 3I2 plus 9I3 equal to 0, or you can divide by 3. So I2 plus 3I3 equal to 0. Take I3 to the other side. So I2 equal to minus 3I3. Equation number 4. So we got one equation between I2 and I3. Now we need one more equation between I2 and I3 to solve. So for that we are connecting equation 3 with one of these two. So equation 3 is 5I1 plus 2I2 minus I3 equal to 2. Now equation 1 or 2, any one we can multiply to make it 5I1. So take equation 2 or 1, any one, multiply with 5. So 5 into I1, 5I1. 5 into minus 2, 10, minus 10I2, minus 4 into 5 is 20I3. Now both are 5I1, so you can subtract C with D. So 5I1 will go 2 minus 10, 12, minus I3 minus 20I3 will be plus 19I3. So the next equation is 5. So you got 12I2 plus 19I3 equal to 2. You got 3I2 plus 9I3 equal to 0. Now you can multiply this 4 and make 12 and subtract. you get I3 from that, or directly you can substitute I2 as minus 3I3. Both will work. Option 1, make this equation 12I2 by multiplying 4 common and subtract, or you already have I2 as minus 3I3, substitute here. When you substitute I2 as minus 3I3, so 3 into 12, 36. So minus 36I3 plus 19I3 equal to 2. Now you add these two, 19 plus minus 36 will be minus 17. So minus 17I3 equal to 2, or I3 equal to minus 2 by 17 ampere. So once you get I3, you can go back to I2. I2 is 3 times of I3 with a negative sign. So minus minus will go. So 3 into 2, 6. 6 by 17 ampere. That's I2. Now for getting I1, we can use one of this equation. So I1 is equal to, you take this to other side. So I1 equal to 2I2 plus 4I3. 2I2 meaning 2 times 6 by 17. So 12 by 17. Plus 4I3. I3 is minus, so 4 into 2, 8, minus 8 by 7. So 12 minus 8, 4. 4 by 7 ampere. So you got I1, I2, and I3. You need to find current through each branch. So current through AB is I1, that is same as 4 by 7. Now current through AD is same as I2, which is 6 by 7. Current through BD, which is same as I3, that is minus 2 by 7. Then current through BC is I2 plus I3, 6 by 17 plus minus 2 by 17. So 6 minus 2, 4. 4 by 17 again. Now the last one, current through BC. BC is I1 minus I3. I1 is 4 by 17. I3 is minus 2 by 17. Minus 4 minus minus 2. So 6 by 17 ampere. That's a current through each branch. So there was a correction here. This is minus 5I3. When you multiply with, when you open the bracket, minus 10I1 minus 5I1, so 15, so 25I1. Then minus 10I2, then this is supposed to be plus, minus into minus plus 5I2. And this resistance was 5 ohms. When there are 3 unknowns coming, we make 3 equations, and from the 3 equations take any 2 and solve to eliminate one of the 3 unknowns. So you try to eliminate here I1. We got equation between I2 and I3. Again take 2 other equations and eliminate I1. So you get 2 equations with I2 and I3. Then that I2 and I3, again you have to equate by making I2 equal or I3 equal, then solve, getting I3 or I2 solve from that. You need to go back to find I1, I2.